And let me just share the screen. So here, share. So you should all be seeing that. And so we'll just talk a little bit about wire and cable today. Shouldn't take that long. We'll talk about wire and cable types, voltage, current ratings, DC cables, AC cables, shielded cables, and coax and transmission lines. So wire comes in many different shapes and sizes. Typically it comes in solid, which is a solid piece of copper or aluminum, or a stranded piece, usually like 7 or 14 strands. Um, and Here's typically household wiring where you have your neutral, your ground, and your hot wire. And then you can also get cables, various different conductors and different sizes. Here is, for example, a ladder line, which is an open type wire of transmission line. Here's a typical coax cable where you've got your center copper wire, you have some form of insulation, then you have your outer shield, which is typically copper or aluminum. Sometimes it can be foil or both foil and copper, and then you have some sort of protection on the outside. And then when you get into larger amounts of RF, you can have something like this, which is almost like two pipes in one another, or two tubes in another. You have this one, which is the RF carrier. You have some type of insulation, and then you have your outer one, and then your insulation. So this can carry, as it's very low loss, and also can carry quite a bit of power, but it's also quite expensive. And then you have your typical magnet wire, which is used to make inductors, and this is wound on a toroid. And we'll talk about inductors next week. So one of the things you need to look at is, the cost of the wire. And the thing is, you should use the right wire for the right job. And you should also, use the best wire that you can afford it. So I mean, a lot of people set up antennas using the speaker wire, which is relatively inexpensive. But one of the things is that if you're going to use this wire, let's say for a dipole, how easy is it for you to replace the wire? If it's very high in the tree or into a mast, if it's only 20 feet up and it's easy to replace, then you could use, more of an inexpensive wire. But if it's something like 100 or 150 feet up in the air, really difficult to replace, then, it's probably better to use a more expensive wire that lasts a long time. So one of the things is that wire will stretch and eventually break through its own weight. The other thing you have to remember also is that uh, a lot of insulation is not UV resistant. So if you're outside, you should have insulation that is provide some sort of UV protection. So if the insulation breaks off and gets damaged, then water can get inside, and then water causes corrosion, and then creates also a stress point. And and the other thing is, if you're going to bury your coax, you should make sure that it's really designed for to be buried. Some are and some are not. And then also, if you're running coax up on a tower, you should get the best coax that you can afford to run up on the tower, because it's a big job to replace it if you have to. So typically, you have solid copper and stranded copper. You can also get aluminum wire. It used to be quite popular back in the 80s and the 90s. It's less popular now because it tends to oxidize. And then also the aluminum and the copper react with one another. and creates problems and can cause fires. So, a lot of house wires did have aluminum wiring at one time. If you have aluminum wiring, it's best not to touch it. But if you start hooking things up to it, then you can, get chemical reactions between the copper and the aluminum. You can get special sleeves to put on the aluminum that help that. But it can be a fire hazard, so that's why they've stopped in general using aluminum. It tends to be a little bit lighter in weight and maybe less expensive than copper. The term wire is typically used for a single item, like a one conductor. Cable is typically used for multiple conductors, and you can get 2 to 100. And then shielded cable could be a general shielded cable, just to for microphones and audio, or you can use a coax cable for RF. So when you look at wire, typically it's the size of the wire, and that determines the current rating. Then you also have the insulation type and the amount of insulation, and that's typically your voltage rating of the wire. And then as I mentioned before, it's whether it's UV resistant or not, and then also whether you can bury it or not. And sometimes if the wire can't be buried, then you may have to put it into some conduit to provide protection. And then the other important thing is the temperature rating. So it's the insulation or the wire itself. Sometimes the wire can heat up, and there's usually a temperature rating associated with the wire. And then also, if the environment is warm or hot, then you might need silicon coated wire or Teflon wire, so it protects itself from the heat in the environment. So these are some of the things you need to look at. Other characteristics is resistance per foot, and this is typically related to power loss. So, the smaller the wire, the greater the resistance per foot. The other thing you want to also look at is weight per foot. And this is, important when you look at antennas, because the wire can be actually quite heavy. And can the supports handle that weight of wire? And then again, the thing is, wire stretches by its own weight. It tends to break. So there may be some wires designed not to break. The other thing is wherever you make a connection to the wire or connect it to, if you strip away the insulation on the wire, like if you go back to the picture here, uh, if you strip, this is usually the part that is mechanically unstable, and this is where it tends to break. And if you also strip away your insulation and make a little nick here by accident, that's also a weak point where the wire can break. So typically, they use the whole wire to connect it somewhere mechanically and then strip off the insulation just to make the electrical connection. And I've found with some uns and some other wires that I've just had in a case or in a cart going back and forth for breakfast every morning. If this thing was supposed to be glued down by double-sided tape in a commercial un, but it broke loose, and then just the walking up and down and the un going up and down broke this connection here. Although I still got it out to San Francisco with a 1/4 inch wire antenna. It still worked for some reason, but it broke off at the connector. And then also when you solder this, the solder tends to run inside the cable and can also cause it to act more like a solid piece and might break off here. And then also when you strip off the wire, you may break some of these strands, or when you stick this into one of these terminal strips, some of the strands may not go into the hole, so there are little ferrites you can put on top of it to help you make those connections. Um, Shielding. Do you want to keep signals out or in? So it may be important. And then, do you want to protect the wire? So some wire has metal cladding, such as Lumex or BX. These are typically for power applications. And then you may want to put it in some conduit or some pipe or some flex to protect it if you need to protect the wire. When you come to coax and transmission lines, typically impedance, 50 ohms seems to be the standard for amateur radio. 75 ohms seems to be the standard for video transmissions, although they can be somewhat interchangeable. You're worried about dB loss, so that you're concerned that depending on the frequency you use, by the length of the cable and also by the size of the cable. If you're getting above 500 watts of power, then you want to look at the flexibility rating of your wire, and um, you look at the size of the wire. If you're getting up above 500 watts, that becomes an issue. So you need to use some of the larger one. Flexibility is the other thing. How often are you going to move the wire? And they have turning radius recommendations, like how many degrees you can make a turn in the wire. Otherwise, it could damage the wire. And are you going to leave it in one place, or are you going to take it up and down like soda and poda? Cost is a big factor. It can cost anywhere from maybe 50 cents a foot up to like $50 or $60 a foot, depending on what, or even more with the bigger sizes of coax. And then also coax gets damaged if water gets into it. And it's usually the first 6 inches to a foot after the connector that gets damaged. So you want to water seal the connector. And then your connectors can range, from $5 to $50 each. So, if you want to get a really good end connector, that's, you get the best, but that's going to cost you $50. So you have to figure in, how much is your coax going to cost? How much are your connectors going to cost? How much is it going to cost if you have to replace the coax? Like if it's buried and goes up a tower, you may want to spend more money and not having to replace it. So you got to factor all of these things into it. Wire sizes. Typically, often if you buy appliances, it can be undersized. So, feel it if it gets warm. If it gets really hot, don't use it. You probably put on the wrong size. Um, Sometimes you get poor quality or counterfeit cables, especially extension cords in the past. It looks like it's, size 10 wire or size 12 or 14 wire, but it might only be like size 18 wire inside because insulation is cheaper than wire. And, so check, if you buy an extension cord at the dollar store or something like that, check to see how it works first and see if the extension cord gets hot. This is especially important now, with people running air conditions. It used to be heaters in the past. Now it's air conditions because they would take quite a lot of power. And then also sometimes the conductors are not designed to bend too much. So if you have a loose connection, like at a plug or at like an entry point to an appliance, that area can get hot, and then you shouldn't be using that, and you may need to replace it. And you shouldn't put extension cords under carpet or behind furniture, especially if you don't know if it's going to get hot or not. And often people use the wrong size. Um, for air condition, you should really use size 12, but not 14 or 16. And then other people use too long of a wire. And then people tend to buy the cheapest. So don't if you're going to use it. Um, make sure you're buying the good one. You don't want to start a fire in your place. So typically, when you're looking at AC for house wiring, it's typically 14 AWG, which is rated at 15 amps typically. 12 is usually rated at for 220 and 20 amps. And then 10 is used for 220 and 30 amps. But check your electrical code and your bylaws because they could change. And then typically for DC, you you use different sizes, and typically here you're more concerned about the current and how long the wire is going to be. So I've got some tables coming up to show you. So here is just a typical example. It varies also by how many cores you have in it, and also how many wires you have to get. So if you look down here, 14, which is your typical one, single core, they say it's rated up to 24 amps, but I mean, I wouldn't use it right at the extreme. 3-core stranded would be 15 amps, and then it goes down depending on how many cores you have. And here are your different wire sizes, 8. So, 14, 16, and 18 is typical for your extension cords. 12 is a better extension cord. Here is just an example. 1.5 millimeters is about 14 AWG, and it just shows you that if you have number of conductors and putting wires into conduits and things in walls, the current rating drops. So this is again something you need to look at if you're running wires in pipes. Your local electrician should know all of these things. Now, when it comes to DC, for 12 volts, typically what they're looking at is a 3% voltage drop. And so one of the things you have to remember is that if your radio is 15 feet away from your battery, you should actually, because it's 2 wires, you should actually be looking at 30 feet. And then here's how much current your radio is carrying. So, typically, I mean, some of the radios might be rated like at 23 amps. So, you're looking at, size 8 wire, size 6 wire, size 4 wire. So it's fairly big wire. And this is mainly because you want to keep your voltage drop low. And again, use the adequate wire otherwise you could start a fire. And then also have a fuse that's close to the battery and also close to the radio. And then here's just a graph of showing, what sizes you should use. So, if you're going to size 10 wire, which is the orange one, 20 amps for 5 meters. And then as the wire gets longer, it drops down. So, at 20 meters, you're probably only supposed to use it at about 7 amps. So this is where your larger size wire comes in, like your green, which is number 6 wire. And typically this wire is stranded because you have to run it around various parts in your car to get, or in your shack to get from the power supply to your radio. So here is just, a way to do the calculation. If 3% is 0.36 volts. If your manufacturer of the radio says, you should have less than 0.36 volts of a voltage drop, you need to use a bigger size wire. And so that's basically it for wire. So any questions on that? Let me just stop sharing and turn off the recording here.